generate over 100,000 volts DC. This can be done with a circuit shown. This circuit consists of only two types of components: capacitors and diodes. Capacitors have the ability to store charged particles. As charged particles flow into a capacitor, the voltage across it increases. When charged particles flow in the opposite direction, the voltage across the capacitor decreases. A diode allows current to flow in the forward direction, but blocks current trying to flow in the backwards direction. To understand how this circuit operates, let us consider just one stage of this circuit. Suppose we provide an AC voltage input to this circuit, which is a voltage which is constantly changing directions. At this moment in time, diode 2 is blocking the current trying to move through it in the backwards direction, and diode 1 is allowing current to move through it in the forward direction. Therefore, current will flow into capacitor 1 and cause it to develop a voltage across it. Capacitors have the ability to store charged particles. When the AC input voltage changes direction, diode 1 will now be blocking, and current will flow through diode 2, causing capacitor 1 to discharge and lose its voltage, whereas the capacitor 2 will be charged and gain voltage. A diode allows current to flow in the forward direction, but blocks current trying to flow in the backwards direction. When current flows in the forward direction, both sides of the diode are at about the same voltage. On the other hand, when the diode blocks current from flowing in the backward direction, the different sides of the diode can be seen at significantly different voltages. When the AC input voltage changes direction again, diode 1 will allow current to pass through again, thereby again charging capacitor 1. Diode 2 is blocking the charged particles from leaving capacitor 2, and capacitor 2 therefore keeps its charge and its voltage. When the AC input voltage changes direction yet again, diode 1 will block current from flowing through it, and the only path the current can take is by passing through diode 2, thereby discharging capacitor 1, but charging capacitor 2 to an even higher voltage. We now have a situation where the output voltage is higher than the input voltage. When the AC input voltage changes direction again, diode 1 will allow current to pass through again, thereby again charging capacitor 1. Diode 2 is blocking the charged particles from leaving capacitor 2, and capacitor 2 therefore keeps its charge and its voltage. When the AC input voltage changes direction, diode 1 will now be blocking, and current will flow through diode 2, causing capacitor 1 to discharge and lose its voltage, whereas the capacitor 2 will be charged and gain voltage. Every time this cycle repeats, capacitor 2 will be charged slightly more, and its voltage will increase. Diode 2 will prevent it from discharging. After we repeat this cycle a number of times, we will eventually arrive at this situation, where the DC output voltage is double the peak value of the AC input voltage. If we are able to accomplish this with just one stage of the circuit, then by using many stages of this circuit, we can obtain an extremely high DC output voltage. However, this circuit is not capable of delivering a large amount of current to the output due to the fact that this would cause the capacitors to lose their charge, and the voltage would therefore go down very rapidly. But if we don't care about supplying current to the output, and we only care about creating an extremely high DC voltage, then this circuit is extremely useful.